Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have understood Myhill-Nerode Theorem for DFA minimization with the help of a solved example. And now in this lecture, that is Myhill-Nerode Theorem solved problem, we are going to solve and understand one more problem on Myhill-Nerode Theorem. So the topic for this lecture is Myhill-Nerode Theorem, which is also called table filling method. So the problem is minimize the following DFA by applying table filling method or Myhill-Nerode theorem. So this is the DFA given to us and we need to minimize this DFA by applying the table filling method for DFA minimization. So what was the first step in the process of DFA minimization? The first step is to remove all the unreachable states from this diagram. If you observe this diagram carefully, from the initial state u, there is no unreachable state. All the states are reachable from the state u. And you can verify this because I have explained how to check unreachable states multiple times in the previous lectures. So, in this particular diagram, there is no unreachable state. So, we are done with the step number 1. Now, we'll move to the step number 2. That is, we need to draw a table for all pairs of states. Let's see the table. This is the table that we have drawn for all the pairs of states of this particular diagram. I have explained you in the previous lecture how to draw this kind of table. Column-wise, you need to ignore the first state, that is u. So if the states are u, p, q, r, s, t, then column-wise, we don't need to write the state q. We start from P, Q, R, S, T. And row-wise, we don't write the last state, that is T. So we write U, P, Q, R, S. And column-wise, we have 1, 2, 3, 4, 5 states. So we have to draw 5 cells. 1, 2, 3, 4, 5. Then we can draw 4 cells, then 3, then 2, then 1. And in this way, we can get this type of table. Now, as per the next step, we need to mark all the cells representing the pairs of states in which one state is a final state and another is a non-final state. So we don't have to mark the states in which both states are final states or both states are non-final states. If one is final and another one is non-final, then only we have to mark that particular cell. So let's check all the cells one by one. The first cell is PU. This one, PU. P and the second one is U. So P is final and U is not final. That means it is satisfying the condition. So we can mark this particular cell. Next is QU. Q and U both are non-final. So we will not mark this particular cell. RU. We have R and U. R is final and U is non-final. So we can mark RU because it is satisfying the condition. Then we have SU. S and U both are non-final. So we cannot mark SU. Then we have TU. TU, final, non-final. So we can mark TU. Next is QP. Q and P, final, non-final. So we can mark QP. Then we have RP. So we have RP. Both are final. So we cannot mark RP. Then we have SP. SP, final, non-final. So SP can be marked. Next we have TP. TP, both are final. So we cannot mark TP. Now we have RQ. R and Q, final, non-final. So we can mark RQ. Now we have SQ. SQ, both are non-final. So we cannot mark SQ. Now we have TQ. T and Q, final, non-final. So one is final, another one is non-final. So we can mark TQ. Next we have SR. SR, final, non-final. So we can mark SR also. Then we have TR. T and R, both are final. So we cannot mark TR. Last cell is TS. T and S, final, non-final. So we can mark TS. So this is the table that we have received after performing this particular step. That is, we have marked all the cells representing the pairs of states in which one state is final state and another state is a non-final state. Now, what is the next step? As per the next step, we need to check all the unmarked pairs one by one. In general, if the unmarked pair is p, q, we need to calculate delta p, x, delta q, x. And if that particular pair is marked, then we also need to mark p, q. So, for all the unmarked pairs, we need to check the pair of their transitions on the input symbols, that are 0 and 1. And even for the one input symbol, their transition pair is marked, then we have to mark the original pair also. So let's check for the first unmarked cell, which is QU. So here we will write QU, and for this we need to calculate delta Q0 and delta U0. Now Q0. Q0 is R and U0 is P. So we can write R, P. Now let's check R, P in this table. RP, this one. This is also unmarked. No issues. Let's check for the next input symbol, which is 1. So now we will write delta Q, 1 and delta U, 1. Q, 1. Q, 1 is R and U, 1 is T. So we will write R, T. Let's check R, T also. R and T, this one, RT. This is also unmarked. So here we will write unmarked, and since both are unmarked, that means QU also will remain unmarked for this particular iteration. Let's check the next pair, which is SU. SU. So for this we will write delta S, 0 and delta U, 0. S, 0 is R and U, 0 is P. So here we will write RP. RP we have just checked that it is unmarked. No issues. Let's check for the next input symbol, which is 1. So here we will write delta S, 1, delta U, 1. Now S, 1 is R and U, 1 is T. So here we are getting R, T. That also we have just checked, which is unmarked. Since both the pairs are unmarked, that means SU, this pair will also be unmarked. Now let's check the next unmarked pair, which is RP, this one. Now RP, for this we will write R, 0, P, 0. Now let's check delta R, 0. R, 0 is R and P, 0 is Q. So we are getting RQ. Let's check RQ in this table. RQ. RQ is marked. So here we will write marked. And since RQ is marked, so we will mark RP also as per the given condition. But just for practice, let's check for the another input symbol also. That is 1. So here we will write delta R, 1 and delta P, 1. Now R, 1 is also R and P, 1 is S. So we are getting RS. Let's check RS in this table. RS. This one. This is also marked. So RS is also marked. So we can mark RP. RP, which we have already marked. So even if one was marked, we can mark RP. Fortunately, both are marked, so we can definitely mark RP. So RP has been marked in this particular iteration. Next unmarked pair is TP. So for TP, we need to write delta T, 0, delta P, 0. Now T, 0 is S and P, 0 is Q. So we are getting SQ. Let's check SQ in this particular table. SQ, this one, which is unmarked. Let's check for the input symbol 1, delta T, 1 and delta P, 1. T, 1 is giving Q and P, 1 is giving S. So we are getting QS. SQ is same as QS, so this will also be unmarked. Since both are unmarked, we cannot mark TP. This cell will also remain unmarked. So till now we have got this table. Now we need to check for the next unmarked pair, which is SQ. For the SQ, that is this particular cell, we need to write delta S, 0, delta Q, 0. Now S, 0 is R and Q, 0 is R. So we are getting RR. This is an example of pairing of states in which both the states are identical. And I have explained you, such pairs are not present in our table. That is why we will write not present. Let's check for the next input symbol. So here we will write delta S comma 1 and delta Q comma 1. Now S comma 1 is also R and Q comma 1 is also R. So here we will get R comma R, which is also not present in our table. Since both the pairs are not even present in our table, so we can never mark S comma Q. S comma Q will always be unmarked in any iteration. So even in the next iteration, we need not to check SQ once again, because SQ will always be unmarked in this particular table. Let's check for our last unmarked pair of this particular iteration, that is TR. So here we will write TR, and for this we can write delta T comma 0 and delta R comma 0. T comma 0 is S and R comma 0 is R. So we will write SR. Let's check SR. SR. This is marked. So here we will write marked. Since SR is marked, so we can mark TR also. TR can also be marked. But just for practice, let's calculate for the symbol 1 also. Delta T comma 1, delta R comma 1. Now, T comma 1 is Q and R comma 1 is R. So we will get QR. Let's check QR. QR. This one is also marked. So we will write marked. Since both are marked, we can mark TR. Even if one was marked, we can mark TR, which we have already done. So after performing the first iteration, this is our final table. Now we have to perform the second iteration. So we need to check from the first unmarked pair once again. So the first unmarked pair is QU. Now for QU, we need to write delta Q comma 0, delta U comma 0. Now Q comma 0 is R and U comma 0 is P. So here we will write R comma P. Let's check R comma P this time. This time R comma P is marked. So here we will write marked. Since R comma P is marked this time, so we can mark Q comma U also. Let's check for the input symbol 1 also, just for practice. We don't need to check for the another input symbol, actually, if for the first input symbol it is marked. But just for practice, let's write for the second input symbol also, which is 1. Delta Q comma 1 and delta U comma 1. Now, Q comma 1 is R and U comma 1 is T. So here we will write RT. Now for RT, which is this particular cell, it is also marked. So we will write marked. And that is why QU, which is this particular pair, is also marked in the second iteration. Now let's check the second unmarked pair, which is SU. Here we will write SU. And now we have to write delta S comma 0, U comma 0. Now S comma 0 is R and U comma 0 is P. So here we will write RP, which is marked. We have just checked. Now for the input symbol 1, delta S comma 1, delta U comma 1. And delta S comma 1 is R and U comma 1 is T. So here we will write R comma T, which is also marked. We have just checked. Since both are marked, we also can mark S comma U. Even if one of them was marked, then also we can mark S comma U. So this is the table that we have got till now. Now let's check the next unmarked pair, which is TP. So here we will write TP. For this we need to write delta T comma 0, delta P comma 0. Now T comma 0 is S and P comma 0 is Q. So here we will write S comma Q. Let's check S comma Q. SQ. It is unmarked. So here we will write unmarked. Let's check for the input symbol 1. Delta T comma 1, delta P comma 1. Now T comma 1 is Q and P comma 1 is S. So we are getting Q comma S. Q comma S and S comma Q is same. So we can write unmarked. Since both are unmarked, that means T comma P, this particular cell, will not be marked in this iteration also. Let's check for the last unmarked cell, which is SQ, this one. So here we will write SQ. For this we need to write delta S comma 0, delta Q comma 0. Now S comma 0. S comma 0 is R and Q comma 0 is also R. So we are getting R comma R, which is not even present in our table. Let's check for the next input symbol. That is 1. Delta S comma 1, delta Q comma 1. For S, 1 we are getting R, and for Q, 1 we are getting R. So we are getting R, R, which is also not present in our table. Since both pairs are not even present in our table, that means S, Q will not be marked. Now in the first iteration also, I have explained you the case of the pair S, Q. In this particular pair, we are getting both the pairs that are not even present in our table. So in the second iteration, we need not to even check and write S, Q again. Just for your practice, I have again taken the pair of states S, Q. But in the examination, you need not to write and check S, Q again if you have already checked it earlier. In the first iteration, while checking S, Q, you need to properly mention that for the states S, Q, we are getting the pairs of states that are not even present in our table. That means S, Q will never be marked. In this way, you can write the proper reason so that you need not to check S, Q again in the next iteration. So this is the table that we have got after performing the second iteration. And if you notice, in the second iteration, we have got some significant markings in our table. That means we can say that markings are still not stable. So we need to calculate the third iteration as well. The two pairs that are unmarked for the third iteration are T, P and S, Q. These are the two pairs T, P and S, Q that we need to check in the third iteration as well. T, P is giving the pair S, Q and S, Q is unmarked, and I have just explained you that S, Q will always be unmarked in our table. That means T, P will also be always unmarked in our table. So in the third iteration, we can conclude that T, P and S, Q will never be marked in our table. So we are done with the third iteration as well. Now we can say that no further markings are possible. So this is the final table that we have got after performing all the iterations. Now what is the last step? The last step is to combine the states of the unmarked pairs. There are two unmarked pairs, T, P and S, Q. So we need to combine T, P together and S, Q together so as we can get the minimized DFA. That means from the original DFA, the states U and R will remain as it is in our minimized DFA also. But the states P, T will be combined together as a single state of the minimized DFA. Also, the states Q and S will be combined to form the single state of our minimized DFA. First, let's combine P, T and we will get PT. PT is the final state of the minimized DFA because P and T are the final states of the original DFA. Similarly, we can get Q, S combined as this particular state. So these are the four states of the minimized DFA. Now let's complete the transitions. U on 0 gives P and U on 1 gives T. So we can say that U on 0, 1 gives P, T. So here we can draw U on getting 0, 1, we will get P, T. Now P on 0 gives Q and P on 1 gives S. T on 0 gives S and T on 1 gives Q. So we can say that PT on 0 and 1 gives QS. So here we can draw PT on 0, 1 gives S, Q or Q, S. Now Q, S on getting 0, 1, the next state is R. So similarly we can draw for the state S, Q on getting the symbols 0 and 1, we will reach the state R. This is the minimized DFA that we have got after minimizing this particular DFA by applying the table filling method or Myhill-Nerode theorem. You can see that our original DFA contains 1, 2, 3, 4, 5, 6, total 6 states. And our minimized DFA contains just 1, 2, 3, 4 states. In this way, we have minimized this DFA by reducing the number of states. So we are done with our topic, that is Myhill-Nerode theorem. So this was all from my side for this lecture. Thank you and I'll see you in the next lecture.